Hello friends, so today we are going to talk about how to deal with system failures by designing a system that is going to be robust and reliable. So without any delay, let's get started. So first let's try to understand that what are the different types of failures that can happen in any particular system. So number one type of failure is a hardware failure. This can be anything. Maybe your disk is going out of bounds, or maybe your networking having some issues. Maybe your system they just crashed, or there can be some power outage. There are a lot of scenarios which you can't control and maybe hardware can fail. Second type of failure can be a software failure. So this deals with something like buggy code, or maybe you are using outdated version of any particular language. Maybe the third party libraries you are using, they are outdated, they needs to be updated. And there are a lot of reasons that can cause a software failure. Third one is a human failure. And this is always going to be there as long as you have individuals who are touching or playing your production servers or making some changes. Humans are prone to error. Any such kind of things can happen that can cause a system failure. And the last one is the external factors. So external factors can be anything that are way beyond your control. Maybe something like a disaster happened. Maybe some third party item that you are using or library you are using turned out to be that was causing an issue. Maybe your systems are reliant on some other company or some other service to provide you the data, and that service fails. So these are things that are going to be out of your bounds, and you will need to design a system that can handle all of these types of failure. So let's see that how can we design a system that is going to be specifically prudent for failure. And number one rule is don't have single point of failure scenario. Whenever you are building something, designing something, be it be load balancer, application, or your web server or your app services, anything that you are running, you don't want to have just a single copy running in any of your system. Let's say that you have a very robust and very nice looking system, but in all of the system, you only have one single API gateway that deals with all the other components of your database. So in that scenario, even if all of these things are well replicated and you have good enough copies, still what if this particular chunk of piece or this system fails? Then your entire system is going to be crashed. So don't have single point failures. Always make sure that you are using the concept of redundancy, where you are at least having multiple copies of each web server or each type of application or load you are running. This can be anything. This can be your web server, this can be your application server, this can be your load balancer, this can be a caching mechanism. If you feel that you are storing some important data into the cache, that should not be destroyed abruptly. So all of these things you need to make sure. Next one is replication, that you need to make sure that you are well replicating all of your resources and all of your data. So even let's say that throughout the day you have this huge system that runs like a fine machine, and you have a lot of transactions that are happening. Now all of these transactions are being stored in one centralized database. Now imagine what would happen if this centralized database in itself gets destroyed or maybe ran into some issues. Your entire system would be failing. So once again, for all the type of data that you are dealing with, entries you are dealing with, logs you are dealing with, always try to replicate them and store them in, if possible, geographically different locations. So you are dealing with a scenario where you are not running into a single point failure scenario, or you don't have just one copy of the sensitive data or information that might come in handy. Now next one is that how you are going to ensure that your failover happens. So for that, you will need to have a robust system that can automatically detect that there are some issues happening. Let me give you an example. Let's say that you decided that you are going to have multiple copies of your web application that is running your logic. And currently you have a load balancing system in between, and you have your transactions coming in. Now, for the security purpose or whatnot, you decided to distribute the load evenly across all three servers. Now suddenly, as it happens that this server decides to crash, maybe some power outage, some issues, whatnot, faulty hardware, we don't know. Now in this scenario, you want to detect that or you want your load balancer to know that this server is currently no longer working as expected. Then only load balancer would start routing all the traffic that were intended for this server to other servers, and your system is going to be prone to the failures. So in that scenario, you will need two things. Number one, you will need to have additional copies of your existing workload that you are running. Number two, you need to have a mechanism that detects automatic failure, that okay, hey, that this is the issue happened and now I have already detected that. Third thing you need is automatic failover. So transferring all the load that was mathematically 33.33% load was going to this data, now transferring that to the remaining database. So this also needs to happen, and that is called failover mechanism. So there are a lot of examples of failover mechanism. Maybe you have multiple copies, so you are routing the load in round robin fashion, and then you take the server that contained faulty mechanism out of the existing pool of available servers that your application can communicate with. There are also scenarios like maybe a blue-green server where one server is just there for backup. So let me give an example of that scenario. That suppose currently your 100% load is being handled by this server, and this server is there only for the backup. Now, the moment we realize that this server is failing, automatically our entire load should be switching to the second server. Now, what do you think in your opinion? Is this a good strategy or a bad strategy? Well, one way it's a good strategy, it's a cheap strategy, because you are having replication of web server gateways that are up and running. But in case one system fails, you are routing 100% load to the other system. And what if worst case scenario, this system also fails? In this case, your entire system is going to be bust. So this is a good strategy whenever you have a low critical type of scenario where you can handle failures for maybe some time, and you can build a system like this. This is one more designing pattern. Now let's see that after realizing this, that these are the different options we have, how can we detect the failures that are happening inside our system? And for that, we need to have two things that are most important. First one is the monitoring, that all of our service should be monitored continuously for all the applications that are running in. And second one is alerting. Now there are a lot of different tools available for each one of them. Tools like Dynatrace, or even for alerting there is like PagerDuty or maybe ServiceNow. There are a lot of cloud native tools available like Azure Insights, or Amazon has also their own services. Google has their own services. So there are tons of different options available to us, but you need to make sure that all of your applications that are running currently in the system, they are all being monitored through any one of the mechanism, and those logs, they are continuously checking that your services are up and running or not. And for simplicity, I'm just drawing one single logging mechanism, but typically it's going to be a separation of logs that are going to be handled. Now, on top of using monitoring tools such as like Dynatrace or Azure Insight, Azure Monitor, whatnot, you also need to make sure that you are taking care of the logs and alerts and health checks. So health checks is very important, because health check is going to allow you to know that any particular system suddenly stop working or not. So how health check typically works is that, let's say that currently I have these 3 servers running. Of course, they are taking in the transaction, they are running, and they are dealing with all the traffic loads, the business logic side of things they are doing. And we are also logging that information into the logging mechanisms as well. On top of it, we are also going to have a service that is continuously going to check for the health for any particular application, and it is simply going to make one call and expect a call back saying that yeah, I'm currently working fine. And as long as we get this information, we are going to dictate that these are good services that should currently stay within our system. The moment we find out that there are some issues, we will take that server out, because through health check we will be able to detect this immediately. And these brings us to the last topic, that how can we handle the system failure in the real time, because this is the most important. Many of your services, they are going to be 24/7 running, and you don't need to have any downtime, which means even if at 2 a.m. something goes wrong, you will need to handle your services to take care of all the issues that the failures happen in the real time. For that, combination of all things that we discuss comes into the place. Number one, we need to have proper load balancing or API routing mechanism. where because we have multiple copies of any particular server, the moment we detect that there has been a failure happening, we need to route all of our traffic to to the remaining good available servers. Same goes with the database. Because we have replicated database, instead of relying on just one piece of data, if we are not able to reach there, we at least have some backup option to reach to some other place. Now next one comes up is that the moment production incident happens, we also wants to notify the team that is responsible for handling that production server. Maybe some issue with the code was happening, or maybe it was not able to take enough performance, maybe the auto scaling didn't work. So in that case of scenario, you want to have an incident management portfolio that is being created for your scenario. How does that work is that, let's say that currently I have this application that is currently running my workload for the payment services. Now immediately some transactions started failing, and then I realized that there is some issue happening. Now depending on the severity, it can be either priority 1 issue, priority 2 issue, priority 3 issue, whatnot. Let's say that worst case scenario, this was the priority 1 issue, which means every single transaction for this for our workload is completely failing. In that scenario, what do I want is that the team who is responsible for handling this scenario, I want an incident being created for that team, and that team being notified maybe through their cell phones, or maybe through their laptops or email address, or maybe a call to their manager or their VP, whatnot. But I want to have a system that does this automatically in real time the moment this type of error has been detected, which means I'm taking care of a lot of things. First, I'm taking care of health check, because I'm checking that whether this call is working or not. Next, I'm taking care of monitoring. I'm monitoring all the logs that are happening. I'm also taking care of load balancing, because I realize that all the available servers, they are all failing. Next, I'm also taking care of that what is going to be the failure mechanism. Currently we tried all the options. Maybe we tried to increase the number of nodes, restart the server automatically, they all started failing. So at the same time, we decided that we are going to alert the existing team members so they can have a look and they can resolve this issue pretty quickly, rather than waiting till next morning and hearing about the complaints that are coming from the consumers. So this now suddenly this makes your system much more robust and much more available. So this is one of the key parameters that you will also always have to understand, that why this happened. On top of it, once the team comes into the picture, you can also try to think about that what was the root cause for this type of failure. You can also have a scenario where you can have a scenario where you automatically roll back to a previous version. So if you have sufficient CI/CD pipeline available, and you have proper parameter setup, you can also say that, hey, if the calls are failing in the existing server, maybe revert it back to the previous version of the workload that was running fine, and then route all the traffics. Meanwhile, we fix the existing issue for that, why this failure happened. So there are a lot of different options and a lot of scenarios available to us. But always remember, whenever you are trying to build any sort of system, make sure it is robust, it is well replicated, there are no single point of failures, you have appropriate health check mechanisms, you are monitoring, you are alerting, and you have automated rollback strategy, automated scaling strategy, automated changing strategy, and also all of your workloads are distributed, geographically located in a distributed area. So you don't want your entire server to be running in just one city. What if there has been a natural disaster happening in that city, which means that's it. Even if you had all of these things, still your servers cannot bring up. There was a huge power failure and that crashed your entire system, and maybe potentially it can cause reputational damage or financial damage to your company. So always remember that these are the different scenarios. And over the next few days, you are going to be seeing me make bunch of different system design videos where we are going to be designing things like Twitter, Netflix, Amazon, tinyurl, Zoom, or whatnot. Okay, so over there we would be able to discuss all of these things in much deeper manner. Now let me know in the comments, what do you think about this video? Is there anything else I could have done better to make it more interesting?